Online students, could you please confirm? Yeah, done. Okay, guys. So let's start the session. So in the last class, we are discussing about the inferential statistics. And today we are going to conclude the inferential statistics. And within the inferential statistics, we have seen the multiple types of test. What are the various kinds of tests we are having? We have observed. Not clear. Could you call them once? Voice figure out. So within the inferential statistics, we have discussed about the null and alternate hypothesis. And alternate hypothesis. So here there is an option. What is that option means? Inferential statistics is nothing but concluding. We are going to conclude based on the evidences and based on the given sample. We are going to conclude something. For example, our null hypothesis says that the person is innocent. The person is innocent. And alternate hypothesis is the person is criminal. These are the two options. Here we are going to estimate. We are going to estimate, or we are going to inference, or we are going to conclude. We are going to conclude, or we are going to estimate the null whether it is a null hypothesis we have to accept, or we have to reject the null hypothesis based on the sample. What are the sample we are having? We are going to estimate. Our estimation would be 1. Reality may be 1. Okay, estimation might be 1. Reality might be 1. So here estimation we are doing in the inference statistics is called as estimation. And what are the estimation we are doing here? Estimation, or which is also called as inference. We are estimating, or we are going to inference the data based on the sample. Sometimes our estimations might be correct. Sometimes our estimations might be wrong. See here, actual is the person is innocent, means actual is H0. We are also predicting, means we are estimating H0 only. We are also estimating H0. Actually the person is innocent, and we are also predicting H0. This is one option. Okay, option number 1. Option 1 is this. Okay, where option number 2. What is the option number 2 is? The person might be as innocent. You may predict as H1. Okay, the person, whoever the judge is there, the judge will do this. Person is innocent or person is criminal. He is going to estimate that one. How he is going to estimate or inference means based on the evidences. If the evidences are wrong, what judge can do? So here there might be a scenario. There might be a scenario where you are having in terms of actual H0 and predict is equal to H1. Which call it as incorrect prediction. We call it as incorrect prediction. Incorrect prediction. Right? Now, there might be one more option. What is that option is? Actual the person is really criminal. Actual the person is criminal and predicted also criminal, which is called as correct prediction. There is no wrong in this. And actually the person can be a criminal and predicted as a innocent. We are going to predict as innocent. This is also called as incorrect prediction. Right? These are the total 4 options. Actual H0, predicted H0. Actual H1, predicted H1. Actual the H1, predicted H1. Actual H1, predicted H0. So these are the total 4 different options are possible, out of which 2 of them are correct, 2 of them are incorrect predictions. Sir, why we are going to do the incorrect predictions means evidences are like that means what we can do. I mean, in terms of sample data is like that means what you can do. You went to the Kinley water bottle company. Basically, Kinley water bottle company is cheating, but they have provided for the quality inspector very good samples, which are perfectly having the 1000 ml. And what are the analysis they have done on the sample? They are going to conclude that Kinley is a good company. Sample is a wrong sample, then what we can do? So sometimes biased sampling will be there. Based on the biased sampling, biased answers only will come. And at the same time, sometimes random sampling also done also, we may get wrong answers. So sometimes there is a possibility of incorrect prediction. See here, every person will do the estimations or every person will do the predictions. But which person is great means out of 100 predictions, how many correct predictions they are making, that person is great. Every person will make the prediction. For example, in this class, I'm going to predict after out of these 100 people who has registered for the course, minimum 50 to 60 members will get the job. I'm predicting like this, assume. And which student I'm predicting also, I'm going to say this student, that student, like this. I'm going to point out the each and every student name also clearly, and you guys are going to get the job. I have predicted something like this. Now in the reality, the students has not got the job, assume. But how many students I have predicted? 100 students. Out of 100 students, I predicted 60 students will get job. 40 students will not get job. Okay, no, they will not get the job. Assume. I have predicted in this way. Now, for each and every student name, record wise, I'm going to do the record wise for the student 1, for the student 2, student 3, like this, multiple students. I'm going to take up to 100, and which student will get the job? Yes, no, yes, no. I'm going to predict something like this. Yes, this, yes. Like this is my prediction. How you are going to predict means based on the exams whatever you have taken, and based on the mock interview which I'm going to conduct in the future, and based on that I'm going to predict. Some students they may not attempt the exam also. Some students they'll attempt the exam and they'll write, and they'll submit the papers, and though they didn't get the marks also, we are having the marks with us now. So here based on that we are going to predict something, right? So here what are the prediction I'm going to do, right? This prediction will be from my perspective, actual answers will be something else. It might be, for example, for student 1 I have predicted yes, reality also might be yes, reality might be no also. There is both the chances are there. When I predicted no, the reality might be yes, reality might be no. So here for yes also yes and no's are possible, for no also yes and no's are possible. But total 100 students, what I have predicted, in that how many of them are correct? That is my accuracy. I'm not going to say for a single person, sir, you predicted for this person job, no sir, but he has not got the job, so you are a waste data scientist. So here we are not going to focus on a single person, right? We are focusing on a batch. 100 students we are predicting means out of 100 students, and in that how many students, whatever I have predicted, in that how many of them are correct is the accuracy, right? Even in the my earlier I told you stock market, and I have shown you my stock market portfolio and everything, right? So in the stock market also, I'm going to do the prediction only. It might work, it may not work. Both the cases are there, na? Whatever I do in the stock market, everything works means why I'll be here? I'll keep my entire asset also in the stock market only now, right? Now here in the stock market, I'm going to keep the money. It may give the profit, it may not give the profit. Now, how many I'm predicting? How many things I have done overall, how many trades I have executed in the stock market, in that how many of them are profit and how many of them are non-profit is my accuracy. Is the point is clear? So we'll never conclude based on a single one overall, right? Now, here in the inference statistics, we are having the 4 different options. One is actual H0 and predicted H0. Second one is actual H0 with predicted H1, actual H1 with predicted H1, and actual H1 with predicted H0. These are the 4 different options. What you are predicting, that you are accepting. Okay, whatever you are predicting, that you are accepting. For example, here you have written the predict H0. You are predicting H0 means you are accepting H0. Predict H0 is also called as accept H0. Okay, what are the predict H0 you are having? It is also called as actual H0. Sorry, accept H0. Okay, so predict H0 is also called as you are accepting H0. Whatever you are predicting, that you are accepting. If you are predicting H1 means that you are accepting H1. So predicting H1 is also called as what then? Accept H1. You are accepting H1. And you are predicting H1. What is the meaning of predict H1 means? You are accepting again H1. And predict H0 means nothing but it is also called as accept H0. Okay, accept H1, other name of accept H1 is reject the H0. You are accepting H1 means you are rejecting H0. Why sir, again you are confusing? Accept H1 is simple only, no sir. Because we have to tell everything based on the H0. Everything we have to say based on the H0. So here, this one, accept H1 is also called as reject H0. Everything you have to say based on the H0. So accept H0, reject H0, reject H0, accept H0. Everything you have to say based on the H0, not based on the H1. Okay. Now, based on this, we are going to draw the confusion matrix. The name itself, it is called as confusion matrix, as many of them are getting confused. They have given the name itself like that. But no need to confuse. It is one of the most dead easy one. Okay. So what is this confusion matrix means? So one side you take actual, one side you write the predict. Choice is yours. Whichever the side you are interested, you can write. So I'm going to write this side actual. This side I'm going to write as predict. One side I'm writing actual, one side I'm writing as predict. H0, H1, H0, H1. Okay. Now, sir, to understand this one in a simple words, what you have to do is you should not write simultaneously along with me. Just focus what are I'm explaining. Otherwise, if you write simultaneously along with me, you'll be confused. Sir, why this is called as confusion matrix means here multiple opposite words are there. What are the opposite words means? One is H0. For opposite of H0 is H1. And actual opposite word of actual is predict. Accept, opposite word of accept is reject. Correct, opposite word of correct is incorrect. Like this, 8 different words are there and opposite words are there. So when I'm explaining one of them, if you are writing second of them, automatically the brain will get confused. When you are when you are learning in an opposite direction, there is a high probability of brain get confused. Right? When you are listening to the opposite words. For example, one person says that Are he's a good person. Another person says that he's a bad person. Are one more person says this one, that one. So what happens? Finally, we'll be confused. Whether he's a good person or bad person, we can't identify that. So if you have to get a complete clarity, means focus on any one. Simultaneously, if you do both the things, none of them will be completed finally. Right? Because even in the real life also, multiple people, that too for the freshers, what they'll do means after the engineering, they are not having the clarity of what they have to do. So they will prepare simultaneously multiple things. Simultaneously, they'll sit in the data analytics class, they'll prepare for bank exams, they'll go for another class, something. And finally, what happens means nothing will be happen. None of them they'll get settled finally. Okay, they'll not get the bank exam, they'll not get this one, that one, nothing. And again, they'll get a problem. And if they get the job also on the day one, for example, if due to any one of these, if they get the job also, their lifestyle will be in terms of every day. This day, what we have to do to ask others, to depend on others, like this, it will be there. And the career growth also not, there may not be very high, because in your brain so many things you have loaded, nothing you have learned properly. For example, if you are focusing only on data analytics, what happens means after the class we'll focus again data analytics only. Whenever we require in the brain job, again we'll open the data analytics notes only. The moment it triggers the job, immediately data analytics notes. Now if for example if you are focusing on multiple things, what happens? This one, that one, that one, this one, sir, that one has given. So finally confusion. Same thing will happen here also. When opposite things comes, the brain will confuse. Right? Now, so cell number 1. What is the cell number 1 is, what is actual means? Actual, it is H naught. First you write actual word, and later you write the predict word. Second one you have to take the predict. For this particular cell, what is actual, from this side you have to see. What is predict means, this one you have to see. This cell is a combination of these two. It is a combination of these two. So these two combination you combine like this. Actual H naught, predict H naught. Actual H naught and predict H naught means whether it is a correct prediction or incorrect prediction. Correct. You have to write the first word called as correct means correct, incorrect means incorrect. First word should be correct. Correct or incorrect? Correct. What you predicted? H naught you have predicted. What is predict H naught is also called as? Just now I told you, predict H naught is called as accept H naught. So correct acceptance of H naught, it is called as correctly accepted H naught. Means the person is innocent. You also predicted the person is innocent. You correctly predicted the person is innocent. That is the meaning of this. This particular cell is clear for everyone? Okay. Don't write now itself. My suggestion. No sir, you want to write means continue with the same. And if you get confused means don't ask me again. Okay. Suggestion only. It is not compulsory. If you are interested, you can write. Simultaneously you can write. Now coming to the cell number 2. Cell 2, first what you have to tell? Actual. Second what you have to tell? Predict. First tell me what is actual. Actual is H naught. That is this line and this line. Combination is this cell. Actual is H naught. And what is predict? Predict is H1. After writing this one, now you have to write in terms of whether it is a incorrect or correct. Incorrect. First word should be incorrect or correct. That is incorrect. What you predicted? Predicted H1. Predict H1 is called as what? Just now I told you. Predict H1 is called as what? Predict H1 is also called as accept H1, which is also called as reject H naught. So this is called as reject H naught. Incorrect rejection of H naught. Is the point is clear for everyone? First what you have to write? What is actual? What is predict? You have to write. After that, first word correct, incorrect. Second word accept H naught, reject H naught. Total 4 things you have to write. Actual, predict, incorrect, and what accept H naught or reject H naught. Total 4. In every cell you have to write like that. Now coming to this cell. What is actual? What is predict? Actual is H1. Done. What is predict? Predict is H naught. Done. Actual is H1. Predict is H naught. Perfect. Now, next coming to the correct or incorrect. So first word should be either correct or incorrect. Incorrect. Accept H naught or reject H naught. Huh? Predict H naught. What you are predicting, that one. Predict only you have to focus. Predict. What you are predicting? Predicting H naught you are predicting. Predict H naught is called as accept H naught. Is the point is clear? Right? If you want, you can see here. Accept H naught. Predict H naught is called as accept H naught. Next, last cell. Coming to the last one. What is this? In this, what is actual? Actual is H1. What is predict? Predict also H1. Both are H1. Now it is correct or incorrect? Correct. First word is correct. Second word is what you are predicting. What you predicted? H1 you predicted. Means you are accepting H1. You are accepting H1 means rejecting H0. What you are predicting that you are accepting. Opposite to that is you are rejecting. So this is correct rejection of H0. That's it. This is the matrix. Everyone is clear? Anyone has any questions, you can ask. If no questions, we'll try with one more example. First you write in the notes this one. Later we'll try with one more example. Done? Now let's try with one more example. Now, in the second example, this time I'm going to take here predict. This side I'm taking the predict. This side I'm taking actual. Sir, that side actual. No, sir. There is no rule like that. There is no rule like that. You can take which side actual, which side predict, your choice. Okay? Choice is yours. There is no rule. In some textbooks, you'll find this side predict, that side actual. In some textbooks, that side predict, this side actual. Okay? That is absolutely fine. Now, even this one, H0, H1, H0, H1. Now, cell number 1. What is cell number 1? What is actual? What is predict? Actual is H0. Predict is also H0. And what it is called as? Correct acceptance of H0. Correct acceptance of H0. Okay. Now, coming to the cell number 2. This one. Cell number 2. What is in this actual and what is predict? Tell me. Actual is H1. Predict is H naught. Correct or incorrect? Incorrect. 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 Acceptance of H naught. Whatever you are predicting, that one. What you predicted? I asked first first question what I asked for you. What is actual? What is predicted? I asked. What you told for actual? You told actual is in terms of H1. Predicted is H naught. Whatever you predicted that you are accepting. Now coming to the cell number 3. What is actual? Actual is H naught. What is predicted? H1. Okay. Then it is correct correct or incorrect? Incorrect. Reject H naught. Next, what is actual? What is predict? And what is correct or incorrect? Reject of H naught. That's it. What was interchanged to earlier? This one asterisk is there. These two has interchanged. The second and third positions are interchanged. Because why? These two are interchanged. So those two are also interchanged accordingly. So when you are seeing the confusion matrix, first thing you have to observe is which side actual is there, which side predict is there, that you have to observe. Okay, sir, in one of the textbook I have seen this side incorrect acceptance of H naught, sir. Okay, that side predict is there then. Okay, so while reading, don't focus only on the center one. Left side, right side, what is there? And coming to in my interview, okay, I will give like this. In my many people, I'll ask whenever I ask the confusion matrix, they'll write something blindly. Internally, they'll write. Now, for those people, what I will do is I'll write here this side predict. This side I will write actual, and this side I will write H1. This is H naught. This is H naught, and this is H1. This is my interview question. Not even H naught will be the same. This is going to be the interview question, and I will ask where is incorrect rejection of H naught is there? Where is incorrect acceptance of H naught is there? I will ask the questions like this. Now, why sir, what is the use miss? It eliminates the by heartness. Otherwise, what happens? Center 4 values, they'll by heart and they'll come to me. Now, concept will be, it is not going to be by heart now. Only to the persons who knows concept, only those people can answer the question. It eliminates the by heartness. Right? Just fill the values, 4 values. Which is incorrect, which is correct. Fill all the 4 values. You do now. Without saying the previous one. Please don't see your previous, whatever I have explained that one. Don't open that matrix. Blindly do this one. If it is clear, do. If it is not clear, ask. What are the doubts you are having in this? So I'm going to tell you the shortcut for this to write the values, the 4 values to fill. Which side we are having the predict, that side you have to write the accept. Accept H0, accept H0. Which side you are having the H0, predict H0, that side you have to write the accept H0, accept H0. Which side you are having the predict H1, predict H1 is also called as reject H0, reject H0. Both are same means correct, both are opposite means incorrect. Both are same means correct. And this H1, H1 correct, both are same, so correct. And H1, H0 incorrect. Simple like this. Which side you are having predict H0, there accept H0. Where you are having predict H1, reject H0. So for example, predict like this is there, sir. Upside predict is there. Then you have to write here accept H0, accept H0. Predict H0, predict H0. Now I have written row wise. Row wise accept H0, accept H0, predict H0, reject H0, reject H0. Row wise I have written. If it is predict is on the column wise, you have to write in the column wise. That is the shortcut. Is the point is clear? Now see incorrect, earlier incorrect is here. Now incorrect has came to this position. There is no rule that incorrect acceptance of H0 will be in the second cell only. Incorrect rejection of H0 will be in the third cell only. Nothing like that. Concept is locked. Is the point is clear, guys, for everyone? Now, incorrect acceptance of H0, wherever it is located, it is called as type 2 error. Whether it is in the second cell, in the third cell, wherever it is called as type 2 error. Incorrect acceptance of H0 is called as type 2 error. Incorrect rejection of H0 is called as type 1 error. Wherever it is located. Incorrect rejection of H0 is called as type 1 error. Don't lock the cell number 1, cell number 2 like this. Concept is locked. What is that concept is? Incorrect rejection of H0 is called as type 1. Incorrect acceptance is called as type 2. Incorrect acceptance, incorrect rejection. H0 also you no need to say H0. Why you no need to say H0 means everything is based on the H0 only. By default it is H0 only. So incorrect acceptance you are saying means incorrectly you are accepting H0, incorrectly you are rejecting H0. Everything you are saying based on the H0 only. Is the point is clear? This is called as confusion matrix. Matrix is confusion but concept is this one. Everything is clear? Everything is clear, guys? Anyone has any questions? Online students and offline students. Whoever are having the questions, please ask. Based on the confusion matrix and this one. Now, miss, next we'll move on to the next topic. That is how to convert a skewed data to normal distributed data. Next one is how to convert a skewed data to normal distributed data. How we can convert a skewed to normal distributed data, miss? So, converting a skewed data to normal distribution data is also called as transformation. Variable transformation or future transformation or column transformation. Okay, transforming. You are transforming means you are converting from one to another. Okay, you are transforming the data from one to another. Okay, so future transformation or variable transformation, converting a skewed data to normal distributed data. Now, why we have to do this one? Means answer is very simple. In order to calculate the confidence interval, or in order to make with respect to statistical test, we have to convert the skew data to normal distributed data. Even in the machine learning, of course, you guys are not having the machine learning, but in the machine learning, what are the data we are going to share to the machine? It has to be normally distributed, then only we can share it to the machine. So before to sharing to the machine to learn, it has to be normally distributed. So in your case, it is simply to apply the statistical test. Before to that, the data has to be normally distributed. Okay. Now, how to convert? How to convert a left skewed data to normal distribution data means we are having total three options for that. One is called as exponential transformation. Second one is called as power transformation. Third one is called as Box-Cock transformation. Three options are there. Okay, using the three options, we can convert the left skewed data to normal distribution. That is, whatever the left skewed you are having, that will be converted to right skewed. I mean, normal distribution. Total three options are there. Which option is best? There is no rule like that. If there is a rule like that, then no need to explain the remaining two for you. Then I used to explain only one, which is the best one. That one only I'll explain. Remaining two, I have to explain for you. Right? So there is a no rule like that. Why there is no rule, sir? Because in the reality, all the data sets will not be the same. Some data sets will have the left skewness of -2. Some will have -1.4. Some will have the skewness of -10 also. Even -4 also. Something. So different data sets will have different levels of skewness. For one of them, power may work. For one of them, exponential may work. For one of them, Box-Cock may work. So we have to do the trial and error. So we have to try all the three options. What are the three options are there? We have to try one after one. So when we have tried first option only, it was normally distributed. Should we try the second option? No need then. If first one is not working, second one is not working, third one. Which should be the first one means anything is okay. Finally, I want normal distribution data. In what way you have converted, not a problem. Answer is required. Is the point is clear? Now, similarly, how to convert a right skewed data to normal distribution data means log transformation, root transformation, and along with that Box-Cock transformation. Total three transformations are there. Again, so Box-Cock transformation can be used for both the purposes. Whereas log transformation and root transformation exclusively for right skewed. To convert a right skew to normal distributed data. Is the point is clear? Now, sir, what is meant by transformation? With an example, we'll see one by one. Clearly, we'll see one by one examples. Now, so here, before moving to this one, if you remember in the NumPy, whatever we have discussed in the NumPy, just a minute, NumPy. So if you recollect this one, today's class, now what I'm going to explain it is easy. Here, A is equal to 0, 1, 2, 3. NumPy array of 0, 1, 2, 3. np.exp of A. What is np.exp of A? Exponent. What is exponent? So first one, how you got 1 here? How you got 1 here? Huh? How you got 1 here? E power 0. So first value, for every value you are applying the e power. That is e power 0, e power 1, e power 2, e power 3. Here 0, 1, 2, 3 are there. So e power 0 we have applied. Here for example 15 is there. Then e power 15. E power 1.5 is there here. Automatically e power 1.5 will be applied. What are the number is there? E to the power of. And next one is log A. What is meant by np.log A? it is applying the logarithmic on the each and every value. NumPy means for loop. For every value, it applies the logarithmic value. First, it will take the 0. For it will apply the log. Second, it will take the 1. It will apply the log. So each and every value was converted to log values. This is only called as log transformation. And this is only called as exponent transformation. Basically, converting every value to its logarithmic value is called as log transformation. Converting every value to corresponding its exponential values is called as exponential transformation. Right? Now here, just I'm going to load one data set for your understanding purpose. Okay, let's try with one data set and in the how it works, everything. Now here I'm going to work on a data set called as stroke prediction data set. Means whether the person has paralysis stroke or not. Which type of people are getting the paralysis stroke? Brain stroke problem. It is a brain stroke problem which is from healthcare industry, where it consists of total 43,400 records are there. Okay, and this kind of project only you are going to do in the analysis, in the further analysis. When, sir? Once today we are going to complete the entire inference statistics and all these things. Now tomorrow matplotlib and seaborn we are going to discuss. Tomorrow matplotlib and day after tomorrow seaborn. So next 2 days we are going to discuss the plots. Once plots are completed means everything is completed for you. In the Python plots I am showing. If I show the same plots in the Power BI is completed. Same plots if I show in the Tableau will be completed. So first time I am going to explain for you the tomorrow plots I am going to show now. When I am explaining the plot, whether it is in the Python, whether it is in the Tableau, whether it is in the Power BI, concept will remain same. Syntax only changes. In the Python, you have to write the code. In the Power BI, you have to write in a different way. In a Tableau, you have to do in a different way. So if you want as an example, tomorrow one data set, whatever the data set I am going to select now, that data set I will show you in the Tableau. The same data set I will show you in the Power BI. The same data set I will show you in the Python also. Then why they have created all these 3 different things means that you'll understand in the tomorrow's class. Once we start the project, automatically you'll understand. Right? Now, before moving to the tomorrow's class, first let us focus on today's class. So here this is a stroke prediction. Where stroke prediction is, we are going to analyze which type of people are generally getting the stroke. So here we are having the ID, gender, age of the person, whether the person is having the hypertension or not, heart disease, earlier any heart disease problem is there, and he has got married, and what is the work type, and what is the residence type, average glucose level, BMI, smoking habits, whether the person is having the stroke or not. Okay, here hypertension 0 and 1 is there now. Hypertension 0 and 1 is considered as 0 is considered as the person is not having the stroke. 1 is called as the person is having the stroke. Okay, why 0 only considered as no, sir? Why you can't? Why 1 is considered as yes? Why you can't take 1 as no and 0 as yes? Why you should not consider like this in opposite way? Means very simple answer. It is alphabetical order. First n comes followed by y comes. Alphabetical order. So whenever you get a data set which is already converted to the numeric like this is called as encoded data. Whenever you receive a encoded data like this, in that encoding will be done by default with the alphabetical order. And that too, when they share the data set, they will tell you clearly what is hypertension, and along with the hypertension, what are the categories inside that. They will tell you. So what is that one is called as nomenclature. Okay, one by one we'll enter into that. So let us focus on the today's class. You'll one by one we'll enter into that. Unnecessarily no need to discuss here, because that order of sequence of project is there, that is a different order. That we'll see after once this one is completed. This topic is it will complete in next 15 minutes means. From there I will tell you the sequence of data analytics project. Then automatically you'll understand everything. Right? So continuous variables. What are the continuous variables we are having is age, average glucose level, and BMI. Okay, and remaining all of them are categorical variables, discrete variables. Now for continuous variables, we are going to apply the describe function, where you are going to have the mean, median, and 25 percentile, 50 percentile, 75 percentile, minimum value, maximum value, all these things you are going to get by using the describe function. Already I told you what is meant by describe. So describe means in one shot it gives the all the values. Now let us start with the age column. So total how many columns are there here? Continuous variables, age, average glucose level, and BMI. 3 columns are there. For each and every column, let us cross check the skewness value. For age, what is the skewness means? Minus 0.10. It is normal distributed. Second, BMI 0.89. It is slightly right skewed, but it is still considered as normal distribution because the value is between -1 to +1. Average glucose level 1.67. It is considered as right skewed or positive skewed since it has crossed more than +1. Right? Now, for right skewed distribution, what type of things we have to apply for right skewed? Log, root, box cock. So I'm going to show you how to apply each of them one by one. Right? Now, first let us start with the log transformation. What is meant by log transformation means converting each value to its log value is called as log transformation. Okay. Now, so here what is the column I want to apply? Average glucose level. For this particular column, these are the values. Now, what I'm going to do? np.log. I'm applying the np.log on df of average glucose level. Now, np.log of 0, 1, 2, 3 means what it is going to give? Log of 0, log of 1, log of 2, log of 3. Now, same way, np.log I'm applying on these values means what it has to give? First value, it has to give the np.log of 95.12, log of 87.96, log of 110.89. Okay, log. So here I'm going to use the calculator. In the calculator, let us open and let us write first value. What is the first value? 95.12, for which I'm applying the log. What is the value I have got? 4.55. Next, 87.96. Now let us try for 87.96. I'm applying the log. What is the value? 4.47. So those are going to be the values. First value is going to be 4.55. Let us cross check whether we got the same answers or not. First value is 4.55. Second value is 4.47. Is that clear? Similarly, remaining values also. For every value, it is going to apply. Log transformation is clear now? Just it is applying the log on each and every value. It is also 1D array only now. Just the data is in the column wise. It is a series now. I have selected a single column which is a series. Series is a 1D. Just it is applying on the 1D for loop. Again, it is going to apply the for loop. For each and every value, it is applying the log basically. Right? Now, this column, whatever conversion was done, after conversion, I'm going to store into a new column name. Some new column name I'm going to give. What is the column name I'm going to give is called as AVG, average glucose level. What are the average glucose level is there now? AGL, average glucose level underscore log. Underscore log means it has applied the log transformation. Now, let us in our DF. So it is going to create a new column called as AGL underscore log, a new column. Now for the column, whatever it has created, that particular column, I'm going to check the skewness, AGL underscore log. What is the skewness? It is 0.93. What is the before to skewness? First skewness value is this one. This is initial skewness and this is the converted skewness. Is the point is clear, everyone? So just applying for every value logarithmic, and after what are the column you have generated, for that you are checking the skewness. For the new values you are checking the skewness. Clear now? Now similarly root transformation. Now for root transformation, what I am going to do means for every value, again one more time, this is your original one. Okay, original data. For the original data, whatever the original data is there, for the original data, I am applying the root transformation. What is meant by root means x to the power nth root of x, or x to the power of 1 by n. That is called as root transformation. X to the power of n is called as power transformation. Power 1 by n is called as root transformation. This is called as root transformation. This is called as power transformation. That n might be anything. N is not a fixed value. If n is a fixed value, it is called as, for example, n is equal to 2, it is called as square root transformation. If n is equal to 3, it is called as cube root transformation. When n value is not fixed, it is called as nth root transformation. Sir, why it is not fixed, sir? Again, I am saying, if everything is fixed, then what you will do? As a data analyst, what you will do? If everything is fixed, what you will do? For all the types of data sets, for all, in the reality, in the whatever the data sets you are going to get, everything is locked means what you will do? Copy and paste, huh? No, na. So one data set will have one type of behavior pattern. In one data set, you will get clean data, one data set you will get unclean data, one data set will have outliers, one data set will not have outliers, one data set will have skewed data. So we have to observe and we have to execute. Projects means getting the data set and submitting within the half an hour. It is not called as project. We are not going to complete the projects in half an hour or 1 hour or in 1 day. In a company, the project is done means it is going to be for 3 months to 4 months. Every day, 8 hours you are going to work. Per day, 8 hours into 5 days also 40 hours. For 2 months project, it is going to be 8 weeks. 8 into 40 hours means 320 hours. What you will do 320 hours? Copy paste. Huh? No, na. Everything is not fixed. 320 hours we have to spend only on a single project. We are going to spend only on a single project for 320 hours means what type of analysis, what everything, if it is fixed, everything will be completed in just 5 minutes only, right? Why it will take that much of time then? Is the point is clear? So it's all depends. So nothing is fixed because reality data is not fixed. We are going to have wide variety of data. So when we are having different types of varieties of data, different ideas we have to implement. Right? So this is the original column which is having the 95.1 to 87.42. I mean, like this. I'm going to apply power 1 by 2. Power 1 by 2. What is meant by power 1 by 2? It is applying the square root on each and every value. So just first value. What is the first value? 95.12. For 95.12, it is applying power of 1 by 2. That is square root of 1 by 2. Square root of 95.12. Next, square root of 87.96. Square root of 110.89. Square root of 69. Like that for every value, it is applying the, and you are going to get the output like this. That is power 1 by 2. You have to take here power 1 by 2 like this. Otherwise, what happens means, as per Bodemar's principle, first it will apply the power 1. Power 1 means nothing but same number divided by 2 it is doing. So as per Bodemar's principle, it is working. So here clearly write power 1 by 2 clearly like this. Then square root of 95.1. See, I'm opening the calculator one more time. Just I'm taking 95.12 and applying the square root. What is the first value? 9.75. Next, I'm going to take the next value, that is 87.96. Okay. 87.96, and for that I'm applying the square root, that is 9.37. Like that for every value. And what are the values you have got? I'm going to store in a new variable called as, let us give the name called as AGL underscore root transformation root. That is the name which I'm going to add. Okay. Now after giving the name, it has created a new column, and what are the column it has created? For that particular column, I'm going to check the skewness value. Dot skew. What is the skewness value? 1.31. Now what is your original one? Original one is this one. Original one is 1.67. 1.67 to 1.31 I have got, okay, fine. But whether it has decreased? No. It is a normal distributed? No. Square root is not working, means try for 3. So 3, what is the skewness value? For 3 it is 1.19. Let us go with the 4. 1.12. Let us go with 5. 6. 7. Here I am writing 7. 8. 9. Next 10. It is not working still. 11. And 12. So 12th root has brought to below to 1. Is the point is clear? Sir, we have to try like this one by one number, sir. One way is this one. Sir, I can't try like this one by one, miss. Apply the then loop. Loop is there now to repeat the code. To repeat the code, you are having the loop, right? So here I am going to take the average glucose level power 1 by n, where n value starts from the 1, and I am going to increase every time plus 1. So first what it is going to take? First it will calculate power 1 and what is the skewness value. And the skewness value I am going to store in the S. If S is less than or equal to 1, it has to break. No, S is equal to 2. For 2, what is the skewness value you are going to get? 1.31. 1.31 means it will break. No, it will go back. Next, you got 1.19. Whether it will break? No. Again, it will go back. Like that, it is going to go back and it will only identify for which one the skewness was brought to less than 1 means what is the number? 12. So 12th root, you are going to get like this. Either you can do manually one by one, or you are not able to do like that, means write the code for that. Wherever you want to repeat the code, loop you have to get in your mind. Same code now. Same code I am trying with the different values now. Trying the different values with the same code is called as loop. Whether it is while loop or for loop. Is the point is clear? Just you can apply the same thing and you can calculate. So like this root transformation also will convert. Third one is called as Boxcock transformation. Now what is this Boxcock transformation? Let's understand the Boxcock transformation clearly. So here these are the 1, 2, 3, 4, 5. Let us take these are the numbers. This is original data. Wherever the x is there, it is original data. What is log x means? Log of 1, log of 2, log of 3, log of 4, log of 5. This is called as log transformation. Root transformation. What is root transformation means? 1 to the power of 1 by n, 2 to the power of 1 by n, 3 to the power of 1 by n, 4 to the power of 1 by n, 5 to the power of 1 by n. Every value to the power of 1 by n. This is called as root transformation. Now, Boxcock transformation. Next one is Boxcock. Now, what is Boxcock means? The formula for Boxcock is x to the power of lambda minus 1 divided by lambda minus 1. Where lambda values are between minus 5 to plus 5 other than 1. 1 should not be included. Other than 1, minus 5 to plus 5. If 1 is there means it is going to be infinite value. So it is going to try the different lambda values. In the back end, it is only trying the loop it is applying basically. It is only applying internally the loop. In that loop, what it is going to try means for different lambda values it is going to try. First it will try for minus 5, minus 4, minus 3. Like that it is going to try the different values within that and it is going to give the output. So it will only try the different values. How you have tried for loop for square root, you apply in the Boxcock, in the function itself, it will do automatically. Is the point is clear? It will do automatically. It will only identify the lambda value. Now, so first 1 to the power of lambda minus 1. 1 to the power of lambda minus 1 divided by lambda minus 1. Similarly, second record 2 power lambda minus 1 divided by lambda minus 1. Third record, 3 to the power of lambda minus 1 by lambda minus 1. Fourth record, 4 to the power of lambda minus 1 by lambda minus 1. Fifth record, 5 to the power of lambda minus 1 by lambda minus 1. How you have tried here? N is equal to first 2 you have tried. If it is working means okay. No means 3 followed by 4. How you have tried in the same way? Here also lambda values you have to try. So for some of the lambda value, it is going to be converted to normal distributed data. Now, so here I'm going to apply the Boxcock transformation. When I apply the Boxcock transformation, Boxcock of DF of average glucose level. Right side is this one, Boxcock. When you apply the Boxcock transformation and you are going to get the first array of values, means transform data, along with this is the lambda value for which it was converted. So two things it is going to give. What are the two things? One is transformed data, converted data. Second one is in terms of lambda value. So here what it is going? It is giving only the transformed data. It is not giving the n value because n value was applied by us. It is just giving only the transformed data. Now, for example, in this loop, okay, here I am printing the n. Along with that, I am also printing this one. What are this? Let us print both of them. This one and this one. First, let me print this one along with this one. Now, can you see? First transform data you got, followed by 12 also you got here. Two things it is going to give. Now, in the same way, can't you create a function for this? User defined function. You will create now. In the function, instead of printing, can't you return the two values? Let us create the function for this one. Now, how to create a function? Def, I'm going to give the some name, root. Okay, no need to write anything. I'm not writing anything also. For example purpose only now. So this is the function. And for this particular function, I'm asking to return. Here itself, I'm going to give the return this value, comma, n value also. Return both the values. Now this function is going to return how many values? Two values. Now if I call this function, what are the function is there? That is root is the function. If I call this function, it is going to give from here to here first array followed by this n value also. Two values it is going to give. Same way, Boxcock also is giving two values. One is transform data. One is for which lambda value it was transformed. Two values it is giving. When it is returning two values, how many variables are required to store them? Left side, two variables or single variable. If you are writing left side single variable means it is going to store as a tuple. If you are writing left side two variables means first one will be stored in the first variable, second one will be stored in the second variable. So here left side I am writing two variable names. What are the two variable names means? One is a new column name, second one is some variable name called as param. Now transform data will be stored in this column, lambda value will be stored in the param. So see like this, it is going to create a new column which is a transform data. And now for the new column, what I have created, what is the skewness value? 0.06. Now, when I applied the first, coming to the original one, what is the original skewness? 1.67. When you applied log, what is the answer you got? 0.93. For log, 0.93. For root, 12th root. For 12th root, what is the answer you got? 0.998 something like this. Not exactly. I'm writing. Now Boxcock. Now by applying the Boxcock, you are getting the value of 0.06. Now three options are there with you. I have shown you three options. Out of these three, which one is best? Boxcock. Why? Because it is more close to the zero. The more the close to zero, the perfect normal distribution. When the perfect normal distribution is there, what are the analysis we do? It is going to be perfect answers. More accurate answers will be there. Is the point is clear? Even I can stop here itself now. Why to apply root? If I apply the log, I got 0.93. Sir, 0.93 no sir. I can stop. You will ask a question like this. Now, instead of stopping, if you try the remaining two options, how much time it will take to apply on a single column? Maximum how much time it will take? 5 minutes on a single column to apply that one and this one. 5 minutes it will take. Instead of asking the question also, it will take 5 minutes only. Na? You are asking that question also, it will take 5 minutes only. If you try also, it will take 5 minutes. 5 minutes is a problem for you to try. Simple. Sir, why to try, sir? Here the point is not the time. Why to try? That is the question. Very simple. Here you got 0.93. By applying the root, you may get 0.04. Who knows? Who knows? For example, in your company, they have given you a target of achieve the target of 70% accuracy. And your work was completed. When within, for example, they have given a project for you. A project target of 0.7, that is 70% accuracy. And the project time was given for you 2 months. 2 months is the time. 70% is the target and 2 months is the time. You have tried all the options and that one, this one, and finally you have achieved the 70% in 1.5 months only. In 1.5 months, your project was completed. Still 15 days is there, time. Now, in these 15 days, enjoying yourself is one way. Opening YouTube and opening Instagram and WhatsApp and seeing them and temporarily time pass, doing the time pass is one way. Or still, though they have, for example, in this 1.5 month, you have got 71% accuracy. Basically, your project was completed. Your target was completed. Your project is also completed, basically. But let us try with still any other options are there to increase the accuracy. For example, instead of 71, the remaining half month also, if you spend the time, and if you get 78% or 80% or something in the while meeting, if you say, sir, you have given the target 70% only, but I have achieved 80%, means whether the person who has given the project will be impressed or not. Obviously, you get one more project now. It's all depends on the individual person. One person will say, why I have to do all these things? I will enjoy myself. One person will think. One person will think that why I can't do still more. And these people who will try remaining half month also sincerely, those people career, they will get from one company to another company. Once they jump means, they will get immediately 50% hike. One of my friend, he has told that I have got from one company 8 lakhs to another company. When I went, they have given 12 lakhs. One of my friend has told me like this. Now, one more friend is there. Now. We are group of friends, right? Another friend, he told that, I also want to shift. Means he got for a 50% hike, means he will also get 50% hike. What is this stupid logic? That person has done some additional efforts. Whether you have done or not, you have to see first. Without saying any efforts, whatever, okay, he has got, means I will also get. He will not get the job, means I will also not get the job. What is this? Right? So in a real world, hikes will not be dependent like that. If you simply jump from one company to another company, you will not get the hike. It all depends on the subject also. Right? It is not like that. One friend has got with 50% hike, means another friend also should get 50% hike. No. For getting the 50% hike, he has done some efforts, it's there. Suddenly the salary will not jump to 50% like that. If a person is getting 20 lakhs package and suddenly next year 30 lakhs package means, do you think that 10 lakhs package increasing in 1 year is simple? That much of simple. Back end some efforts will be there. Every person is not the same now. Some people who are working for 20 lakhs, even they'll not get another job of 20 lakhs also. In that company, they'll get 20 lakhs. If they move to another company, they will not even get 20 lakhs. They'll not even get 20 lakhs. Other company will ask only 15 lakhs. These people will always have the fear. When these people will remove me, when these people will remove me. Tension, tension, tension life. So here the point is very simple. None of them is same. For why I am saying all these things means none of the data set is same. None of the things are same. You have to try your best. You have to try whatever the options are there. for your given data, for the given project, what are the best you can do? You have to give your sincere efforts. Sir, for example, in the same question, what you told earlier, 2 months time, 70% is the target, 1.5 month only completed, okay. For example, 2 months, everything was completed, but I got only 71% also, okay. See, what are the efforts you are keeping within the given time, you give your maximum efforts. I'm not asking to spend entire day or live your family life or live this one, that one, we are not saying. What are the you are spending the time for your studies? What are the time you are spending for the job? In that you give your maximum efforts. The maximum that time was dedicated for job means dedicate for that one only. Don't dedicate for others. You are spending the time for studying means study only. In the study time also again don't see the WhatsApp. Don't see the Instagram. Once you are fixed to study means study. Once you fix it to do that one means do that one. Then focus will be more, target achievement will be easy. As I've told you now, in the stock market, what are the profit I have received now? When I discuss with my friends also will do the something now. When we discuss, they say that, Arey SRK you are getting now, we'll also get. And that too, I will not never open the things in the classroom. Whatever it is happen. Now, as of now, it might be a plus for me, minus for me. What is going on also, I don't know. As of now, I have invested 25 lakhs in the stock market. My present money is there. Yesterday, which I have invested. So today, what is happening also, I don't know. But I don't want to see also. Whatever happens, it is okay for me. Because we have fixed the this class only we have to focus. Other time, other things only has to be focused. We should not combine. Right? So these are the points, guys. Everyone is clear now? Box-Cock transformation, log transformation, all these things. Similarly, exponential transformation. But exponential transformation, you have to apply only on the left skewed data. Sir, if I apply for exponential transformation on the right skewed data, what happens? Still worst result you will get. For example, average glucose level, it is 1.67 now. For 1.67 positive skew, if you apply exponential transformation, it will increase the skewness instead of decreasing. Just give it a try. Okay. So just we are having the different types of transformations. And using the transformations, we are going to convert the skewed data to normal distributed data, and then we are going to apply. Okay. Now, sir, for example, let's take in the inferential statistics how it has to be applied. Now let us go into the main point of inferential statistics, and this is the last point for today's class. So for example, sir, for we are having this data. Okay, this is a fabric data where fabric data consists of 25 samples. For 25 samples, n is equal to 25. Number of records are 25. Now degrees of freedom will be what? Okay, don't fix the 19 number. In that example, 20 samples are there, so you got 19. In this example, 25 samples are there. If it is sample standard, we don't know the population data, population standard deviation means we have to apply t-test. When we apply t-test, automatically degree of freedom will be 24. Right? Every time it is not 19. Right? So here we are having in terms of 25 samples. Now, what is the question they're asking is check whether their average, that is population mean, is more than 150 or not. That is the question. So that is mu is greater than or equal to 150. Mu is less than 150. This is null and this is alternate hypothesis. Okay. This data is not normally distributed. It is skewed. That is the problem. It is a skewed data. Now what we are going to do? Now I'm going to apply the log transformation. When I apply the log transformation, okay, here I'm going to take 4. It is after log of 151.24. Let's take an example, guys. That is not the exact number. Example I'm writing 4.5, 4.2, 4.9, okay, 6.5. Like this, you are getting some values. Now, what are the new values you are going to get? It is normally distributed. Okay. Now, all the values are less than 150 means all of them are less than 150 only now. Then how you can conclude this one? So we are converting this data to a log transform data. Okay, and you are applying the hypothesis test. Win the t test or z test, whether it is t test or z test, you have to provide the input data. Na? What you are going to provide input data, whether this one or this one, which one you will provide, fabric length or log 1. You have to provide the log 1. When you provide the log 1 side, you have to write value, right? Value is equal to 150. If you write, obviously every value is less than 150 only. Na? Now this time you should not write here 150. Then what you have to write? Here you applied the log transformation, means for this one also you have to write the log of 150. That number you have to write here. When you converted the original data to log, this question also will be converted to log. When you converted this data to EXP, this one also will be converted to EXP. When you converted this data to x to the power of 1 by 12, this one also will be converted to 1 by 12. That value you have to write here. You should not write the original value. Converted value you have to write. Otherwise what happens means every value will be less than 150 only, and automatically your null hypothesis will be rejected every time. Is the point is clear? Everyone, if you open your code, what are the code you are having? That is in the first you have to write the column, whatever the column you want to apply the test, comma, for which value you want to apply the test. That value along with the whether it is a left tail or two tail or right tail, you are going to write everything. Right? This value should be transformed value, not the original value. Remember this, that is most important. Right? Now, coming to the different steps of data analytics project. As I've told you, data analytics project. So what are the different steps of data analytics project means? First one is you have to understand the project. What are the project was given to you? First you have to understand the project clearly. Project understanding. Once you understand the given project, then you have to collect the data from the database. Collect the data. Collect the data, how you are going to do? By using the SQL select command. By using SQL select command, you are going to select the data. And after collecting the data, you are going to load the data. Where either you can load the data in the Python, or you can load the data directly to your Power BI, or you can load the data directly to the Tableau. Wherever you are analyzing the data, there you have to load. So for this, I have shown you how to connect the Python with SQL. Okay, once you load the data, now what is after that, what you are going to do? You are going to explore the data. Explore the data means what is the shape of the data? How many rows are there? How many columns are there? In that, which are continuous variables, which are discrete variables? All these things you are going to observe. For continuous variables, you are going to apply the describe function. That is, what is the mean value? What is the median value? You are going to do the data exploration. How you are going to do the data exploration means by using the pandas and statistics. These are the two things. Now, what are the steps included in the data exploration? First, you are going to observe the shape, number of rows, number of columns. Later, you are going to observe the column names. What are the column names are given? You are going to observe the column names. And you will understand the column names. Each and every column name you are going to understand. Data understanding means column name. Every column name should be clear for you. What is the meaning of that? And after that, you are going to check the data types of each and every column. And from there, you are going to observe how many continuous variables are there. And you have to separate them as a list of continuous variables one by one. And similarly, you are going to separate the discrete variables. Okay, now you are going to apply the statistics for continuous variables. What are the continuous variables are there? For continuous variables, we are going to apply the mean, median, mode, and standard deviation, skewness values. All these things we are going to do on the continuous variables. For discrete variables, we are going to write what are the unique values are there, what are the value counts are there, which one is repeated more. Like that, we are going to check. And for continuous variables, we are going to apply the describe function in the pandas. And we are going to draw the histogram, how the data was distributed. We are going to check the skewness. For that, we are going to use the dot skew. Describe, dot describe. Describe will give the mean, median, standard deviation. Measures of central tendency, measures of dispersion will be there. Skewness will give the measures of shape. And histogram will give the distribution of the data and whether the data has outliers or not. You are going to get by using the box plot. So you are going to apply like this, each and everything on the continuous variables, and you are going to observe. For observing these things, what we required? Statistics we required. So after completing the statistics only, you understand all these things now. Without statistics, whether you'll understand this. What is describe function? What is mean? It is 9 batch, right? So describe functions, skewness values, histogram, and box plot. So what are the observations you are doing on the given data? Given data is called as raw data. Data exploration should be done on the raw data. Data analysis has to be done on the clean data. Exploration will be done on the raw data. Original data, we are going to do the data exploration. Explore means we are going to dig that one. After digging the data, now we are going to do the data cleaning. Once we do the data cleaning, then the fourth step we are going to do the data analysis. Now analysis will come. And last step is what are the presentation. So finally, what are the things you have done that you have to present. So what is your last step? Presentation is the last step. This is the, since it is the last step. So whichever is the last step, that is more important for any person. So for you, presentation is more important. So for exclusively presentation, what are the options are there means Power BI and Tableau. They are exclusively data visualization tools. Now the same thing, whether you come to the artificial intelligence presentation or nothing, simply we'll throw that one. So Power BI, Tableau, these are not required for us. For artificial intelligence people, those are not required because their ultimate goal is accuracy. Whatever they are going to predict on that, it should have the high accuracy. For machine learning and artificial intelligence, for those people, presentation only will not be there. What is the difference between you and a data scientist means up to 4 steps, you both will learn the same. Like example of you and 1030 batch. Up to 4 steps, you both will learn the same. There will be no difference. That difference starts in the 5th step. In the presentation. You will do the more amount of presentation. For them, that presentation is not required for them. Tableau, Power BI is for you. For them, Python is sufficient. That too, why Python, why we are learning in the Python means the basic things we'll understand in the Python. When we want to present to others, then diagram should be very low. When we are doing ourselves, whether we do in the Python, whether we do in the wherever it is, that is not a problem. When we are trying to show to others, it has to be looking very good. So for discrete variables, we are going to apply the what are the unique values, what are the value counts, all these things we are going to check for the discrete variables. And data cleaning. Already I have told you the data cleaning, where you are having the wrong data type, all these things. This is the order. Now, once you get in the, tomorrow, once you start a project, once you receive the data, this is the order which you have to do. Is the point is clear? So that is the reason we have discussed in the same order. Whatever we have to do in the companies, That is the order which we are discussing. Now, sir, here Python, we have not discussed some kind of other concepts of Python like exceptional handling or file handling or something like this. Whatever is in the syllabus, we have not covered yet that one. Why? Because very simple reason is in the order, first majorly I required pandas. For understanding the pandas, I have explained for you NumPy. For NumPy, what is pandas means? It is a module. What is meant by module means? It has the functions. What is meant by function means? Internally some code will be there. It will take the input and execute the code and it will return the some output. So to understand the functions, what I have told you before to that, what is code? What is meant by block of code? With that block of code, we have explained for you the for loops. That is the order. Now with the block of code, you understand functions. With the functions, you understand modules. With the modules, you understand pandas. Pandas and statistics is nothing but basically here. Exceptional handling, that syllabus is there. Python is there. But here it will not be used. In this example, it will not be used. In this sequential order, it will not be used. That is the reason I have kept side. But it will be covered. Don't worry. It will be covered. As per the syllabus, it will be covered. Okay, but why I have missed it there and why I have explaining like this, the reason behind this is, once you open one project, once after this, by end of this course, you'll do the one project now. Surely you'll do the projects now. So what are the projects you do now? At the time you will only tell now, sir, why you have not explained those things in between, why you have came in this order only. You'll understand automatically now. Because in the real life, what projects we do, what order we do, I know that one, right? For you, textbook sequential order is important. For me, project sequence is important. Because I'm not focusing on the individual subject wise. I'm focusing on the data analyst role wise. Is the point is clear? Done. In the tomorrow's class, we'll continue from here, which is Matplotlib and Seaborn. Right? If you are having any questions, you can ask. If anyone has any questions, you can ask, guys. If no questions, you can leave.